Good evening, everyone. My name is Paige Refutation, and tonight I will be refuting Eloy's claim of fact that Elon Musk's Hyperloop will fail to work. Now, I disagree and cannot accept this claim for a few reasons. One, the Hyperloop was defined incorrectly. Second, the sources that he used were unreliable. And third, the Hyperloop is still in prototyping phase, therefore this argument is premature. So first of all, what is a Hyperloop anyway? Currently, there is no set definition, therefore we must use Musk's definition because we're debating over his idea. So a Hyperloop is a tube over or under the ground that contains a special environment. In this case, the expected pressure inside the tube will be remained at around 0.015 psi, and this tube will be used as a means of travel for sealed capsules carrying 28 passengers that will have an electric compressor fan on the nose of the pod that actively transfers high pressure air to the rear of the vessel. This will use the same basic principle as an air hockey table. In this case, however, it will be the pod that is producing the air cushion rather than the tube itself. So this definition comes straight from Elon Musk's research paper conducted in 2013. However, Eloy's definition has no sources to back it up, and it is missing key points such as the tube is not completely underground, and he also doesn't describe the pods, which is fundamental in understanding how the Hyperloop works. Now, the reason why you need an accurate definition is because without it, the accuracy of his entire presentation now comes into question. Because how can you make a claim that something will not work when you don't understand how it works? Now, moving along, the sources that he used are unreliable. First of all, he uses almost no engineering sources whatsoever. Two of the main people that he uses are Michael Anderson, professor of agriculture and economics at the University of California, Berkeley, and Dr. Phil Mason, who has a PhD in chemistry and a brief background in physics. Now, although these two both have impressive backgrounds, neither of them are engineers, therefore they are not qualified to speak in the field of engineering, and also neither of them have worked on the Hyperloop project, therefore they cannot speak on the Hyperloop project itself. Now, this demonstrates that his main evidence is faulty and unreliable. Now, another point is that he uses a lot of quotes from Interesting Engineering to negatively describe the Hyperloop. However, inside the same article, Interesting Engineering stated that it is not an impossible task, although with current technologies it will likely remain unfeasible to develop a full-scale vacuum train for many more years to come. Now, this is the biggest weakness of his evidence because it works against his claim. And the biggest problem, though, with his research is that he does not use any information from Elon Musk's research paper on the Hyperloop or from the Hyperloop One website, which is the company who is pursuing the Hyperloop project. Now, this demonstrates a lack of research, and it also weakens his argument by weakening the evidence. So, finally, this argument is premature because as an engineering student, I know that everything starts with the engineering design cycle, which is basically a process of steps that is followed to find a solution to your problem. Now, from my engineering textbook from last quarter, written by Raymond Landis, called Studying Engineering, the engineering design cycle starts off with identifying a consumer need, problem definition and constraints, data information and collection, and development of alternative designs, then evaluating those designs and selecting the optimal design to prototype. And currently, this project was proposed in 2013. It is now 2018, and because of the scale of this project, it will clearly require more than just 5 years to develop a full working prototype. However, as seen on the Hyperloop One website, like I said, the company who is pursuing this goal, they stated that their version Hyperloop One completed its third phase of testing, achieving speeds of 387 kilometers per hour, which is around 240 miles per hour. And the version Hyperloop One is the shell of the proposed design for the pod that is used at the DevLoop test site in Nevada to test the aerodynamics and structural material. Now, this continues to show that their project is still in the prototyping phase, therefore continuing to demonstrate that this argument is still very premature. But also, this quote demonstrates the great progress that they have made, therefore also weakening the claim that the Hyperloop will fail to work. Now, in conclusion, I have demonstrated how Eloy's definition was incorrect. I explained how his sources are unreliable, and I have also demonstrated how this argument is premature. Therefore, we cannot accept his claim of fact that Elon Musk's Hyperloop will fail. But with the increasing positive feedback from the Virgin Hyperloop One website, it is difficult to say that the Hyperloop will be disappearing anytime soon. Thank you.
All right, how we got Elon and Eloy in the same argument, I'm not quite sure. That's going to throw me off sometimes. The advocate's argument is clearly outlined. You're responding to contradictory claims that you've developed. I think that that's pretty good. The first point is basically a definitional issue. You explain what the issue is that you're talking about, how the Elon Musk process is supposed to work. What you need to do is show that the advocate's argument is not using that as clearly. I mean, I understand what you're describing. I don't know that that's substantially different from what they describe. So you need to point out, for instance, that the assumptions that he's using have to do with, different amounts of per square inch pressure. It ignores that the generator of the pressure is in the pod itself, not necessarily in the tube. The notion that it's a vacuum is not exactly, discussed at all, or how much of a vacuum it is. That was, I think, the original criticism that the advocate had, and I'm not sure how your argument addresses that issue. But I do like the fact that you are pretty specific about, this is different than what was described there, and you give us some reason to believe that it's different. I think that you need to kind of remind us what some of the points are that are different on that particular point. The challenge on the second point concerning the lack of credibility for the sources that are being cited, those are okay. They're good general presses on this issue, that we have experts who are speaking outside of their field of expertise. Although, again, I don't know what involvement they might have had with any similar kinds of projects or knowledge that they would have on these things. They may be talking about the general concepts of those ideas. I do think that you have good information that suggests that it's not particularly impossible, that it simply requires an early solving particular problems at different stages, and that's okay. I think you explained that pretty well. The last point, the argument is that it's all premature. This is really kind of your general argument on the whole issue, that we're just at a testing stage here. We can't figure out anything until we've done some of the testing. And so far, the testing looks very promising. We've got reason to believe that it would work. We're at the third stage in this particular process. We're getting favorable results. So the speculation that's presented by the critics it seems to be undermined by the experience that's happening in the engineering process that we're describing. And that's basically what your argument is. If you just say it that way, it would be a little bit sharper. But I think everybody got the point that you're making. And I thought it was nicely and energetically presented. Thank you.